So if we are learning to dissect artworks, one of the critical steps we take is that we analyze the formal elements or the formal structure. Formal means how the artist has formed the artwork, what the artist has chosen to do. So this is a very fun part of art historical analysis, because this is where you actually learn to look very carefully, very deeply, and you learn to observe exactly what the artist has chosen to do, because that is the necessary first step to asking why the artist made those choices and how they were meaningful. So one of the things you learn as you learn how to do formal analysis is you learn to use terms that help you to get more precise in your discussion of artworks. Terms like modeling, which doesn't in this case mean, being a model for a fashion magazine. It means in painting, the process of creating the illusion of three-dimensionality on a two-dimensional surface. So here's Michelangelo again. Michelangelo was also a great painter who painted the Sistine ceiling. And you see how the way that Michelangelo uses a shadowy brown against a lighter brown for the flesh creates the sense that this arm is three-dimensional, that it turns in space, that it has volume and depth, and that the elbow really juts out with that highlight. That's a trick of the artist's trade. There are many, many terms that are helpful to get more precise. Some of them are line. We could talk about the line that the artist uses, the kind of line. Form, how the form of the body turns in space, the way light is manipulated to create shape, form, create a sense of the rising and the falling of the body parts, and color. So color is a fascinating one because it's very intuitive and something we're all intimate with. We all learned our colors in kindergarten. It's one of the learning objectives if you're 5 years old to know yellow, blue, green, red. And you learned which ones were primaries, right? That yellow is a primary, blue is a primary, red is a primary. You know that very well. And that's the building block of what is actually the deep analysis of the complexity of color. This is a copy of a book published in 1839 in French, De la loi de contraste simultané, the law of the simultaneous contrast of color, meaning how they interact. Because colors don't just stand alone. They're actually constantly interacting. And you know that in that yellow mixed with red produces orange. And that can be a yellowish orange or a more reddish orange, depending on how much of each primary. And you know that red mixed with blue produces purple. Did you know that purple is considered the complement of yellow? Because purple is the opposite of yellow. Purple is made out of the primary blue and the primary red. Yellow is the only other primary. So purple is everything that yellow is not, if you will. So I'm not using the word complementary, C-O-M-P-L-I. No, that's not what we're talking about when we talk about color. It's not expressing a compliment, praising, or approving. Instead, it's C-O-M-P-L-E-M. Did I spell that right? Yes. Okay. Which means combining in such a way as to enhance or emphasize the colors of each other or another. In other words, two colors that have the maximum intensity in relationship. So here is a portrait, a marvelous portrait of the great writer Oscar Wilde by the great painter Toulouse-Lautrec. Notice how Lautrec is making the color intense because he's using the complements of orange and blue across each other on the color wheel. So we have this really brilliant, hot, coppery orange with some red in his hair in the background, and then the kind of blue of his suit, and then this other blue, two blues, so that there's an intense kind of popping off or vibration of color hue. What do I mean by hue? So hue is really a synonym for our ordinary word color. It's just a more kind of technical term. And so that's why the text here says the terms are interchangeable. And we could go into the actual physics of it, because color is about how light is made up of different colors, right? There are different wavelengths of electromagnetic energy. To our ordinary eye, we're talking about the rainbow, the spectrum. So let's look at these paint samplers from your ordinary house paint store, at the house paint section at the hardware store, right? And each of these samplers give you one single hue. So this orange here is the same hue as this one. This is a single hue, but they are getting lighter because more white is being added, and that's called value. We can talk about color not just in terms of what color it is, it's this rich orange, but also in terms of whether it's been lightened significantly or whether it's rich and deep and dark, what we could call fully saturated. So all of that is very technical, but it actually exists in order to have you start to perceive the subtleties of color and how dynamically colors interact with each other. So I'm showing you, here's Google. I've Googled Mark Rothko, an important American painter of the 1940s, 50s, and 60s. And his paintings, well, they are many things and they do many things, but one of the things they do is that they explore color in incredibly subtle ways. So they're remarkably simple. Just these flat, squarish or rectangular-ish shapes on a field, but the interaction of a precise color against a different one reveals itself to be incredibly rich. So that if you look at here, the red against the black, this is also black against red, but look at what it means to have the two repeated blacks take up the most of the space and the red seem to be behind it, which of course is not literally behind it since this is paint on a flat surface, but we feel as if the black is in front of and the red behind. Why does this seem to now project forward? There's a marvelously endless complexity to color. One of the best demonstrations of that is the series of experiments with color done by an important artist from Germany who emigrated to the US to escape the Nazis, Joseph Albers. And this is one of his most astonishing experiments because he's setting up colors. You'll see how you have orange and blue, your complements. He's setting up their relationship because what's sort of uncanny is that this square of color is exactly the same hue as this one. These are identical hues, identical values. But because this one is on this particular blue and this one is on this particular orange, our eye reads them differently. So that's why we get very detailed about our technical terms. And color's only one example. We have to get very precise and detailed about space, about form, about light. So that's why we explore the various terminologies used to be able to do formal analysis.